Okay, this video is going to be for lesson 5, which covers sequences of rigid motions, and it's not meant to be a full lesson, but really just an introduction to rigid motions, which we're going to talk a little bit more about in class. The definition of a rigid motion is that it's a transformation which preserves distance and angle measure. And what that means is the image and the pre-image, they're the same shape, they're the same size. But this is a better use of vocab. Facts about this: the pre-image and the image are congruent. And that's all we've studied so far. When we reflect something, it stays the same shape and size. If we rotate it, if we translate it, the pre-image and image have always been congruent for us. So our examples are translation, rotation, and reflection. A non-example, and we haven't studied it yet, but a non-example might be a dilation. And that's because in a dilation, if we have triangle ABC, when we dilate it, it might grow or shrink to become triangle A prime, B prime, C prime. And so in this case, our angle measure is preserved, but our distances, A, B, and A prime, B prime, our distances are not the same. So over on the right, we have a little chart that tells us what changes and what doesn't for our different types of transformations. And distance, the length of sides, that never changed for any of the transformations we studied. Angle measure, they stayed the same no matter what we did. Parallelism, we haven't talked about that, but it stayed the same, and it means if two sides are parallel in the pre-image, they're still parallel after I reflect it, or rotate it, or translate it. Perpendicularity, same idea. If we have a right angle before we rotate, it's still a right angle after we rotate. Collinearity, that means if A, B, and C are in line, A prime, B prime, C prime are also in a line. Orientation, and we're going to look at this one a little bit more, that stays the same in translation and rotation, but it changes for reflection. So let's look at what orientation means. I'm not going to give a definition of orientation. It's kind of how something is positioned on the graph, but instead a test for orientation. So to test, we can travel around a figure and determine if letters go clockwise or counterclockwise. And again, this is really just a test to see if the orientation has changed, not a definition. So looking at our example, we have two triangles. The blue triangle is the pre-image, and the red triangle is the image after a reflection across this dashed line. And if I go around the triangle, and you can go in any order you'd like, I choose to go alphabetically. So if I travel from A to B to C, I'm moving counterclockwise to get around that shape. Then if I move over to the reflection from A prime to B prime to C prime, now I'm moving clockwise to get around that shape. And because that changed, this is an example where the orientation has changed. And reflections are the only ones that do that. When you translate, it's going to stay the same. You might not think it at first, but when you rotate, it actually stays the same for that also. So this is a nice test to see if something has been reflected. Now we're going to hop into the foldable, and we're going to do a little bit of this foldable, but not all. So inside the foldable, the very first example is we have a sequence of rigid motions. And the sequence means that we have done more than one thing to the pre-image to get to that image. And so in this case, we have 3 triangles. And one thing I like to do to kind of make sure that I'm going in the right order is I label them triangle 1, triangle 2, and triangle 3, so I can easily see which one was my first triangle, which was the second, and which was the third. And so we have to, what's happening here? From triangle 1 to triangle 2, what happened? And that is a rotation around the origin of 90 degrees. That's the first thing that I did. Next, to get from triangle 2 to triangle 3, that looks like a reflection, and we can test, is it a reflection using our new rule? ABC moves counterclockwise. A prime, B prime, C prime is moving clockwise, which means there was definitely a reflection here. So 1, 2, 3, they are 4 boxes apart. My line of reflection must be right here. So this is a reflection across the line y equals -1. And Belle is about to write, so I have to quickly get this into function notation. First, I did a rotation around the origin of 90 of triangle ABC. Then I took that triangle, so I'm going to put that whole thing in parentheses. Then I reflected that triangle across the line y equals -1. Composition notation is very similar. It's a rotation around the origin of 90, triangle ABC. And then we have this little circle. And that circle, it really means then. So, or I'm sorry, following. So a reflection across y equals -1 following a rotation around the origin of 90. And so what we're going to look at in lesson 5 is graphing these things. In lesson 6, we'll actually be constructing these sequences, but being able to use this notation where we have more than one transformation happening at the same time. And here, you should actually be able to fill this in on your own, because we know what we have to include for reflection, translation, and rotation. So look back here at your previous lessons and see if you can fill these 3 things in on your own and have them ready.